Completing the square. So we're on to another way to solve a quadratic. There are many ways, so I just want to review a little bit what it means to just complete the square. I'll do a little bit of side work here too. But what we're going to do is we're going to write the equation such that C is on the right side of the equal sign. Now left side or whatever. It's basically me saying this. You want to get those two by themselves, the x squared and the x. Okay, make sure A is 1. For today, all of them will be 1. And what we're looking for is to add a number on both sides of the equation. So b over 2 squared, so b is the number in front of x, divided by 2 squared, add that to both sides. And the reason why it's both sides is whenever you have an equation, you need to make sure it's balanced. Okay, write the equation as a perfect square. And here's an example of something that's a perfect square. And then take the square root of both sides and it becomes a problem to solve by taking the square root. But just quickly, some expressions. Let's say I've got x squared plus 4x, and I'm looking for a number that will make that factor into the exact same thing twice. So I'll take 4 divided by 2. The reason why I picked 4 is because that's my b value. I'm dividing by 2 because that's the formula, and then I'm going to square it because that's the formula. So if I were to do that, 4 divided by 2 is 2. 2 squared is 4, so I would add a 4. So when I factor that, x and x, plus 2 and plus 2, I end up with x plus 2 squared. Perfect square trinomial. Okay, I'll try that again. So I'm going to stick with the same page here, and I'm going to take a negative number in front of x, so a negative b value. So let's say I've got x squared minus 10x, and I'm looking to add. It is always adding. You're never going to subtract a number there. So bring the sign. So that's going to be negative 5 squared, which is 25. So yeah, 25. Now when I come to factor this, it's going to be negatives for both because I have a negative 10, and it's negative 5, negative 5. So x minus 5 squared. That's why I show all my tedious little work. Whatever that number is inside of parentheses, that's what I'm going to end up using in my factoring. 25 is the number that I have to add to complete the square, but minus 5 is the number that I end up using when completing that square. So let's try this with solving. X squared plus 6x minus 8 equals 0. I'm going to bring this over there. So I've got x squared plus 6x. Leave a blank. You don't have to write that blank there, but I think it's a good idea to write it on both sides so you remember to add that number to both sides. So now it's time to complete the square. So I'll take b over 2 and square that. My b value is 6. So 6 divided by 2 is 3. 3 squared is 9. So I'll add a 9 to both sides. Yeah, over here I end up with a 17. And over here I should be able to factor. And it needs to factor into the exact same thing twice. Well, what are the factors of 9 that would be 6? 3 and 3. So x plus 3 squared. That right there is a perfect square. Okay, it factors into the exact same thing twice. So now I can solve by taking the square root. So x plus 3 breaks out of the squared operation. We get plus or minus the square root of 17. Subtract 3, and we get x is equal to a negative 3 plus or minus the square root of 17. Yep. Let's keep on trying a couple. Here again, let's take away the 3, and we'll go x squared plus 12x equals a minus 3. I'm going to add a number to both sides. Half of 12, so 6 squared, 36. So if I color code this a little bit, 36 is the number that goes on both sides. Factor to the left. You might want to factor first just because this has to be the exact same thing twice. If it's not, you pick the wrong number, so 36 wasn't the right number. But in this case, x plus 6 and x plus 6, 6 plus 6 gives you 12. Here you go. I'll write it as a perfect square trinomial, and on the other side I end up with 33. Again, taking the square root of both sides, x plus 6 equals plus or minus the square root of 33. This becomes something like we did earlier in the week. There you go. Now, what happens? There we go. We finally have an odd number for b, and we don't want to look at that odd number so much, because what's going to happen is -3 squared isn't a whole number. Well, I'm going to leave it as fractions. I'm going to not put it as a decimal, so I'll square that. -3 times -3 is 9. 2 times 2 is 4, so 9/4. It will all work out nice in the end, because notice this. When I factor, whatever I had in parentheses, remember, that's going to be what's going to take the spots inside of those parentheses with my x's. So that's a -3 halves, -3 halves. Go back, check out the rest. It's always been that way. So over here, when I'm factoring, it's x minus 3 halves squared. Now over here, I'm going to need a common denominator. So I'm going to have to change that by multiplying the top and the bottom by 4. So there's 16/4 plus 9/4. That's going to give me 25. Add the two tops together, but the bottom stay the same. And look what happens when I take the square root of that fraction. Square root of 25 is 5. Square root of 4 is 2. Okay. Add the 3 halves to both sides. And that gives me 3 halves plus 5 over 2. And x is equal to 3 halves minus 5 over 2. So again, only add the top numbers, leave the top bottoms. So that's 8 over 2, 4. Subtract the two bottom numbers, -2 over 2, so -1. So there's your two answers. Okay. So there you go. That is solving by completing the square. This is something we'll take care of tomorrow. But remember I said that A has to be 1. I'm going to ask you tomorrow in class, what happens if A is not 1, A is 2? So that's completing the square. Or solving a quadratic by completing the square.